Page 327, we're going to start talking about negative exponents. Okay, negative exponents does not mean the number is negative. Okay, it does not mean, it's usually before. So let's say I'm talking about 2 years from now, or that might be an exponent of 2. 2 years before would be negative. It does not mean I'm going negative time, this means prior. So one thing I want you to write down before we even look at this, here's what negative exponents actually mean. If you have 2 to the negative 2 power, a negative exponent goes in the denominator and makes it positive. So it actually means 1/4. And that's true for any exponent. I could have 3 to the negative 4, put it in the denominator, make it positive. That actually means 1/81. And the opposite can be true as well. If I have a negative in the denominator, all that happens is it comes to the numerator and just becomes positive. So it does not mean any negative numbers. If it's in the numerator, it becomes a denominator. If it's in the denominator, it becomes a numerator. We're not going to be getting to that yet. We're just going to be using our rules here for number 1. So if I have the same base, the same big number, what do I do to the exponents? Add them. So 4 plus 0.
4.
Next one is 4 plus negative 1. 4 plus negative 3.
7.
4 plus,
What?
that's negative 3.
2.
4 plus negative 4.
Like just 2.
0 power. And remember, anything to the 0 power is 1. So all those had, or those last 3 had negative exponents, does not mean negative number.
Or if you do have, you already said that.
Question number 2. Marine biologist estimates that the structure of coral has a volume of 1,200 cubic centimeters and that it is doubling each year. Write an equation in the form a plus b to the t. T is the time in years, y is the volume. So why don't you see if you could write that equation just based on that information? Mr. Strang, do you think you got it?
Not yet.
Jackson. Bench.
Nope.
Caleb.
Y equals 1. 1,200 times 2 to the t power.
Yeah, 1,200 is where it starts at. And then it doubles.
Do you need parentheses around the 2?
Don't. Would not be wrong if you had it.
But you need parentheses if it's like a half?
Wait, don't you need parentheses if it's a fraction?
Fraction you would.
So like a half and you,
Well, I mean, the reason you do that so it doesn't look like it's just 1 to that power, right? And then divided by 2.
okay.
So that means 1/2 to the power. That's why it's in parentheses. All right, so let's try it with these numbers. T is 5. T is 1. T is 0. T is negative 1. T is negative 2. So we're going to try all 5 of those. Go ahead and punch them in, see if you can get them.
So you do 2, that, 5.
Times
Yeah,
1200.
okay.
All right. So 2 to the 5th is 32 times 1,200. Everybody got that?
38,400.
And that's cubic centimeters, it said. 2 to the 1st is just 2 times 1,200. Hopefully you knew that one.
1,200.
1,200 doubled.
Yeah.
1,200 times 2 to the 0. Remember, 2 to the 0 is 1. 1,200.
1,200. Cubic centimeters.
2 to the negative 1 now we know means 1/2.
600.
1,200 divided by 2. And this is again is a fourth, so 1,200 divided by 4.
300.
So you can see how knowing exponents can make things quicker for you. But there would be nothing wrong with typing all 5 of those in either. So what does it mean in this problem when t is negative 2? Yes, it means 2 years before the scientist measured the 1,200 cubic centimeters, before the scientist took his measurement, however you'd like to say that.
His.
It says in a certain year, the coral is 37.5. So you'll notice a trend here. 2,400, it went to exponent 0 was 1,200. Negative 1 was 600. Negative 2 was 300. Notice they're going by halves, right? That would make sense because it's doubling after. It means it was half before. So t to the negative 3, if I continue that, it's going to be half of this number. If I do it again, it's going to be half of that number. If I do it again, it's going to be half of that number. And then you have your answer. Which year? Yeah, so negative 5, or probably should say 5 years before the measurement happened. I don't think it gave us a year at all, did it? All right, question 3. The only thing I want you to be aware of for number 3 here is how different y-axes vary your graph. Can change what it looks like. Okay, look at the y-axes on this one compared to this one, compared to this one. Well, if you look at the equation, they are all graphed the same. Which one do you think did the best? I mean, this one's hard to see that it's not linear, right? But it is the easiest to see the 1,200. You would have no idea what this dot is. He went by, I mean, going by 500,000 seems a bit extreme. Here you can see the 1,200 a little easier. So just be aware of the window of your graph. What are you graphing in? Or if you do it by hand, what are you varying your intervals by? Desmos is nice. You can hit that little plus sign with a magnifying glass, and it automatically puts the perfect window there so you can see it. But just be aware. If you're graphing this one, how are you going to know that's exponential? How are you going to know that graph actually curves? You can't see that. So just be aware of that. So I'm just going to put that we discussed that one a bit, that you are aware that that makes a difference. And we're going to go on to the last question, measuring medicine. A person took some medicine but does not remember how much, always a bad thing. Concerned that she took too much, she has a blood test every hour for several hours. Time is measured in hours since it's a blood test. So this is how long it's been since the blood test. M is measured in milligrams. What is the growth factor? That is, what is B in our equation? Okay, so how is this growing or shrinking? It's half. All right, so B is 1/2. And it's always going to be going in positive numbers here. Time obviously goes forward. So what is the A value? What is our initial amount? 100, right here. What I'm starting at. So then my equation is 100 times B to the T. And it wants to know when time is -1 and -3. Caleb.
Would it be 0? But,
Remember, the pattern's going to continue.
oh, it is. Well, so that means that 200. Well, it's.
I mean, you can check it.
It's on, well, it's, oh, no, it's 200 and,
You can check it. Here's the equation.
but why wouldn't it be just 0? Because she put it in, like, she's not gonna just keep gaining milligrams of one medicine forever.
Well, this is when she first started checking.
Right, but like,
I mean, she could have loaded up and then was like, oh, that seems like a lot.
I see.
Checking it here. Yeah, that's not when she took the medicine. So what do we get there?
200.
200.
800.
800. Now, a lot of people say, why isn't that 400? Well, it's skipping -2,
Oh, yeah.
right?
Oops.
And again, you can check it. Use the equation. Okay, so what does T equals 0 mean? What? Initial what?
The time when it equals 0 milligrams of medicine.
No?
No, it's the time when she started measuring.
Yeah, time when doctor did first blood test. So T equals -3 would mean 3 hours before doc did blood test. The medicine was taken when T is -5. So she took it 5 hours before she went to the doctor. How many milligrams did she have in the system?
3,200.
3,200 milligrams.
Quite a lot.
That is a lot. Plot the points. So what goes on the x-axis then?
Hours.
Hours. So we're going to put positive hours over here. That would be hours after the blood test started. And again, this does not mean negative time. Just means before the blood test was taken. So I did just go 3 each way. How high do I need to go on my medicine amount?
Maybe 200.
I'm only going to 3.
800.
800? So I think we can go by hundreds.
Sure.
Try to evenly space them. That'll give you the best graph. That's milligrams of whatever medicine this is. All right, so 3 hours before,
800.
800. 2 hours before,
400.
1 hour before,
200.
0,
100.
100, 50, 25. Okay, so you can kind of see the curve happening there.
It would be 3 hours.
Half of 25.
No, no, no. Oh.
Remember, it's going half each time. Based on your graph, so we're going to use our graph to estimate here. When do you think we'll have 500 milligrams?
About 2.5 hours.
Right before 2 hours, or, yeah.
About 2.5, 2.25 hours before blood test. No medicine.
Well, that's never gonna happen.
So let's talk about when do you think it's minimal that we won't care. So hour 0 was 100. Then it was 50, 25, 12 and a half,
Probably hours.
7.25.
Well,
It's
it's
half of
minimal.
72, 33.75 roughly.
Probably hour 6.
Well, 6 hours is 1.56.
So 7.25 divided by 2, 3.625. Divided by 2, 1.8125 divided by 2. I mean, you're talking less than a milligram here. That's not a lot. But yeah, it's never going to get completely out. It's just going to keep getting smaller and smaller until it's not even detected. So 1, 2, 3, 4, 5, 6, 7-ish. Around 7 hours. Not much left, less than a milligram. It's about. I mean, technically, if you just said it'll never get there, would have been correct too. At some point, though, it gets so low that it does not become detectable. All right, your homework then. There are 7 questions today. Watch for the word explain. There are quite a few that say explain. Just make sure you do that. Obviously, write an equation. Make sure you do that. Just making sure there's no select alls here. And you're starting to see quite a few more graphs there on the second page. I don't think that will be an issue. So 1 through 7 for tomorrow.